This is Dr. J. Mohan from EC Department of Institute of Aeronautical Engineering. I'm going to discuss about the system simulation and modeling. Today our topic is simulation of inventory system. First we must know what we need to study for the inventory system in the simulation model. The inventory system is represented as how much we are going to spend in the or developing the system to take time, and even how it's going to respond, that time also we need to measure. So those case it's going to directly involve with the cost of designing the system. So that's why we go for the inventory of simulation system. Here I take for the inventory of simulation system for some small diagram representation. For the x-axis, it's take for the time, and y-axis amount to spend or to develop. It's represent for the y-axis. So here I represent for the t and I. T is time, I is represents the inventory cases. And even though I represent for the m is represented say how much level we are going to utilize in the inventory cases. So this is a simple representation of inventory system. This inventory system we call for the MN system. Okay, we call for the MN system. M is represented as a inventory amount or inventory time. N is represented as a duration of time to complete for one model. So here I take for the number of model, or here I take for the number of model. Those model it's going to start the work is represented for here. So the model is going to waiting some duration to take the input from the previous state. So this is the output of previous state that we going to connect it with the input. So that input is need to read for our system taking some time duration. That will be have the negligible amount of time duration. Okay, but it's go take for the some amount of inventory. While reading the data, it's take amount of some inventory that will be here. So after some duration, it's take for the n. After time duration, the t I consider as a n. It's produce the output. That output is going to hit for here. The inventory amount is less. Okay. So after the second operation, this operation I consider as a keyword. The second operation is going to happen within that model you need to complete, within the model amount. It's need to complete its process and produce the output. It's have the negative cases. The Q2 is represented as a negative case. But here the time also we take for the n duration. It's producing for the negative. This negative event is called for the negative inventory system. When the negative inventory is going to happen, it's exit more money, or its development is take for the more money. So after that, the negative is going to take, then it's going to give the input of output. Sometimes it's possible to the negative output. That will be going to give the input of another model. It's doing the process is going to complete very short duration, even though it's going to take for the perfect output. Okay, so here I take for the three model. One is represented as average. This is average case. Then it's going to do the process is a medium value. Then it's going to do for the process is a negative cases. Another one it's take for the immediately it's going to produce output. Each interval I represent as a time interval represents a n, n1, n2, n3, n4 like that. So now I simply represent every n time period the maximum inventory level is m. For the maximum level it's going to maybe it's here I represent for the constant. the maximum inter level will be going to have the constant is going to have the maximum level. It's maybe less than our inventory also said. But here the produce output is less than amount. Here negative amount. Okay. So now each time unit, the inventory level is checked and an order is made to be bring the inventory up to the level of M. Okay. So what is that meaning? Each interval level we may measure for the inventory level and we may do for the order is made bring the inventory up to the level of M. If inventory level is not going to match with M level, then we need to bring. Okay. So then the end of the first inventory level period and order quantity is represented as Q1 is placed to bring the inventory level up to M. This repeated at every inventory view. Okay. So this will be going to repeated for the inventory. If we make to find for proper the inventory level of system simulation, then we go and design for the system model. Then we can identify easily how much cost is going to happen when you are going to designing for the any one of the system. That system will be have the number of models are there, whether it be have the continuous, whether it may be the discrete value. Okay. So this is a primary thing to simulation of inventory cost measurement. Next case. If we do for the inventory cases, we need to follow further some potential sources. I have simply represented as a number of potential sources. We need to go for the revenue as well as of cost. First is the revenue from the sales. How much profit we get from the sale. Next, cost of the item sold. For example, requirement. While we are going to designing for the embedded system, first step is represented as a requirement. That requirement is going to involve with what are the component is used at the same time, what are the primary component we are going to buy, then how to execute that model, all it will be going to involve. That cost is represented as a cost of item sold. Okay. Next is carrying cost. The cost of carrying stock in the inventory. Suppose we are using for the transportation, for example of goods need to transport. That cost is represented as a carrying cost. Or if we develop further one model in the system simulation model as like example of LTI system, then we given for the X of 2, it's produce a Y of T as a output. Okay, we given the X of T, produce output. This X of T we need to transport to the LTI system. It's take for the some time duration. It's maybe 1 millisecond or 1 microsecond. The input is going to transmit that 1 microsecond and millisecond. While we do for the any high accurate system design, then this 1 millisecond and 1 microsecond is going to have a very huge amount it's taking to do the process. This 1 microsecond, for example of only one signal we are using, suppose we are using for the multiple signal, we develop for the network connection or we develop for the GSM technology systems, those will be going to take for the multiple number of channels, multiple number of input. If you need to do for the LTE system, then what will be happen? Each channel taking for the 1 millisecond, in the sense it's maybe 1000 channel will be take for the 1000 millisecond. So that 1000 millisecond is very huge amount or very huge time to giving the delay. So that also taking the money. So after that doing the process, this process take for the 2 seconds. After taking the input, doing the process 2 seconds, then after it's go produce the output is Y of T, then we need to check for the Y of T. Those case we call for the carrying stock in the inventory. Carrying stock in the inventory for the system model. If a transport model, its goods are going to transmit. Okay, carrying cost. Next, ordering cost. The cost associated with the place in the order. While we make for the order, for example, you take for the Amazon, we use for the internet. and we use for the some net provider. So while we order, we need to pay for that providers, how much duration we are utilizing that connection for using for the Amazon website. And even though what's the time duration, based on that one, the cost also be going to increase. So that cost is called for the ordering cost. That also we need to make plan for the order cases. Next we go for the cost of the lost state or broken or back order. Okay, cost for the lost sale or back order. So sometime we should lose the sale, or if we the customer is not going to satisfied by the order, or you take for the LA system, this input is not going to support for the doing performance of LTA system. We need to reback for the input. So here we take for the goods, the peoples are not going to satisfy that good, they're going to back order. So that we can take for the some time for the discrete event, or let's take for some duration to for order back to the cases. So we need to spend for the transport also. So that cost also we need to conclude. Then cost due to scrap. If any damage is going to happen, or if the manufacturing unit, for example, 2% of goods are getting to damage when you are going to do for the one shift of manufacturing unit, that is 8 hour, 2% is gone. 2% is going to damaged. If this damage, if you need to accumulate for every day, that will be going to have very huge. But we need to do for the scrap. That cost also we need to include it for the our inventory cases. Then revenue from the scrap or other damaged goods. Okay, if the goods are damaged, that also you can do include. At the same time, damaged good also you need to, while we are going to preparing damaged good also is possible. You know, this 7 step is very essential for the revenue and the cost of inventory system. Next case, when you're trying to improve the inventory system, you face number of trade-off. Okay, so we need to reduce the money to manufacture for the product. We should face for the number of trade-off. First is frequency purchasing or replacement. For the some of the item we are going to purchasing for the frequency, or if you are going to writing the program, some of the instructions or some of the declaration we are using frequently. Then we make it for that one is a global state. At the same time, if we go for the product base, the frequency purchasing, we no need to go for that place to buy for that product. We can make to order because the seller as well as a transporter we know well. So that's why uh, we can going to order and receive the goods. That is frequency purpose. So that frequency purpose we need to identify what are the components we are using for the frequency in the system model. Okay, or replacement. Okay. Next is association cost, associated cost, the ordering cost. This associated cost is involved with your replacement or transport, or even some other case of delaying. All it's going to involve for the associated cost. Next, ordering cost. When you are going to order, then we need to transfer the money from bank to bank. Then they are going to charge in some cost. For example, I say some that will be transfer cost or goods transfer cost, like that will be going up. So we need to go and make how much need, that is called for the trade-off. Cost associated with running out of good. Then storage causing customer to become angry and subsequent loss of goods. So then what the customer is doing, they're going to reback the product. Okay, we need to calculate that cost also. And policy or decision parameter. Based on this one, we make to do for the policy as well as a decision parameter. For the inventory system, the policy has a number of parameters. So here I will say for the some parameter. One is maximum inventory level is we call for the M. The review period I call for the T, that is called for the time N. Then order quality we represent for the Q. Then lead time for replacement we call for the L. This four parameter is very important. The maximum inventory level of M, review probability of M, order quality of Q, lead time for represent replacement. So based on this inventory parameter, we should go and see further some examples. Here I take for the simulation the new dealer problem. Okay. So while we do for the new dealer, first you measure how much profit we are going to receive from the new dealer while we give for our goods or while we give for our model. So we should make to prepare how much profit. Profit will be going to have some marginal level. If lesser than a margin level, we not do for the any business. So daily profit is given by the following relationship. That is represented as a daily profit is equal to revenue from the sale minus of cost of newspapers minus lost profit for exhaust demand plus sleeve for the sale of scrap papers. For here I take for the some newspaper distribution. Okay. For all cases, this is the same formula for the profit of daily cases. Revenue from sale, cost of the product, lost profit for the exhaust damage and the slavage for from the scale of scrap papers. For here I take for one table. The table is consist of A, B, C, D, E, F, G, H, A. So those will be represented as a distribution of newspaper demand. So this is I consider as a this diagram representation. This n values, number of n's are there. So based on that number of m, I make to draw represent by the A, B, C, D, E, F, G, H, A. So what the time? Time is represented as a 4, 5, 6, 7. I given for the some serious cases. Okay. So news distribution level, newspaper. I take for the example. That case we have the two type of cases. One is represented as a demand probability, another is cumulative probability. We need to measure. For the demand, the first day 40 paper, second day 50, 60, 70, 80. It will be increased. Here I take for the order 40 paper, 50 paper, 60 day. But depends upon the day what will be going to have. Then what are the demand probability of distribution of newspaper? So we need to find for the probability based on how much paper we receive. If the good papers, okay, is represented as 0.3 percentage, that is 3 percentage is good, pair is 10 percentage, and the poor is 44 percentage. The next day, 50 paper I taken. The good paper is 0.5 percentage, pair is 18 percentage, poor is 22 percentage. Like that one, we need to measure for every day what the amount of paper. Okay. Based on that one, we make to do for the cumulative probability for each day. So generally we know the probability of any events that is equal to 1. The probability of any event that is equal to 1 depends upon the day. The good is going to vary together. Now I make to do for the cumulative probability of good. So first day 0.3, I make to 0.3. Second day 5. We need to add for this 2. 0.3 plus 0.5 we got for the 0.8. Then fourth day, that is represented as the third day. Our good probability is 0.5. What is the cumulative? 0.08 plus 0.15. We got for the 0.23. The next day, 0.2. Add for the 0.23 to 0.43. Then 0.35 plus 3.5. 0.435. We got for the 17.8. Again, next day, 15. That will be add with 0.78. We got for the 0.93. Next day, that is 0.73. Then we add for the 0.93. So now you can see the good probability is have for the probability is equal to probability is equal to 1. 1. P equal to 1. Okay. So this probability only going to distribute it for the entire events. So our total probability is 1. Then our inventory system is going to work perfectly. Next, we go for the pair. Same like that one. What we are going to find for the good. Like that, one you can add for the 1 by 1. 0.1 first day, then 0.1. Next day 0.18 plus 0.1, 0.28. Like that one we have to find. Finally, what will be happen? Our probability is equal to 1. The pair also will be going to sufficient to find for the inventory system. Next, we go for the poor. That is poor. The demand or the damage. So 0.44, 0.22. That is the first day. Second day, add for the cumulative cases. Third day, fourth day, fifth day, sixth day, and seventh day. Up to how many days are there? We may add the probability is equal to 1 only. No, all the probabilities are 1. So that's why we are directly we go for measure for the inventory cases. It's going to suitable. Next, I take for some example. The sale of $50 per paper and the cost to be dealer is 33% per paper. The last profit from excess demand is $17 for each paper that demanded that could not be provided. Now I take for the day's profit and a day what the day going to have the poor and demand. So based on that one, I make to develop the simulation table. Okay, this simulation table development is depends upon the case of inventory details. I take for the 20 days. Okay, okay, this is represent as index values. Okay, I take them for the 20 days. So first day the newspaper is represented as a fair. Second day also fair. Third day, the fourth day is good. Fifth poor. Okay, we need to measure type of the newspaper, whether the good pair or is going to damage or anything. We may differentiate. Then we may indicate. Then after what the money you are going to send, what the money is going to demand. So first day is $50, second day 50, 70, 80, 40. Okay, depends upon the case of the newspaper you have received. Then we may conclude that type of the newspaper per day. Based on that one, we make to put for the cost. Then after putting the cost, after sale this newspaper, then we got receive for the revenue from the sale. For first day $25, second day $25, like that we're going to receive. Okay. So then after we will do for the last profit from the excess demand. Last profit from the excess demand. What we mean? So after sale, what we will be going to get for the last in profit? If you make to demand in the product, that also you come with this chart. Then that will be taken for the some amount. First day 0, second day 0, third day also 0, fourth day 1.7, like that one we make. Then after you find for the slavage from the sales of the scrap, any damage is going to happen. You can spend it for the some money to scrap on that product. So first day we are going to using for the $1 to $1. There is no demand, there is no scrap. That's why we'll be going to use 0. Like that one you may to make for the table. After that, then you must find for the daily cost. What the daily cost? So you must add for all the cost. This revenue from the sale, last profit of the excess demand, and the salvage from the sales scrap. The cost is here 2.3. See here 25.0000 plus 1. Okay, based on that case, we may measure the cost. Okay, then we find the profit. What the profit we can do for the differentiate with our product as well as what the daily cost is using. So that cost is represented as a daily profit. We measure for all. Someday we got for the loss also. Here I measure, I make to find based on the tabular column, I make to represent for the negative of 1.6 rupees dollar is going to lose at the day. Next day also few days be going to last. Then finally you make to calculate what is the profit of that month or what you are going to specify for that duration. That is 114.7 dollar they're getting to profit. So what is it going to infer from this table? So the sale, or if you are going to buying and selling for the any product, okay. So it's not getting for the daily in profit. Sometimes it's going to have a loss. Based on the loss and profit, finally you may calculate that what you are going to get the profit of, but that 20 days in the selling of newspaper. He's got to benefit of that day month is $114.7. Okay, this is the way we need to measure for the what the profit is going to happen using the demand table. Next case, simulation, inventory policy. While simulation, we need to do for the some policies. Okay, what the policy we need to do? We can make it for the fixed review period. That means each and every time. Are you seeing this diagram? This time duration I mentioned for the n. Okay, this time duration is represent for the fixed level, fixed review period. We take for the fixed review period only. Okay, so then only is going to analyze. If you take for the different way, this is going to take for the 1 minute. This is 1.5 minute, 1.2 minutes, like that. It's going to happen for the random. The simulation inventory case is not possible to measure. Okay, so now we need to do for the order up to level of m comma n inventory policy with a fixed review period. I represent for the n. A maximum inventory level is m. The random demand and the random lead time we need to measure. So what is this? This is n. This is vt. Okay, n it will be represented as a fixed review period. That be duration of these durations. Okay. Then, if we need to do for this case, the simulation inventory policy we got for the order quality. If order quality is not there, there is no useful for the inventory measurement. The order quality is equal to order up to level. Which level they're going to make the take for the MATLAB simulations. How many level you are going to buy? How many simulation tool you are going to buy? Based on that only your cost is increasing. So now we go for the order quality. What the cost while you are going to ordering? What the cost is going to happen? So first is order up to level. Which level you are like? You don't have any some decision to make this much in the order. Order up to any level. Minus of ending inventory. So what the inventory is going to happen for the output. Ending inventory always need to have one, then shortage of quality. So which one is going to shortage in the system? That also need to measure. Here I am going to take for the two distribution tables. One is daily demand, another one is a lead time. So the daily demand I take for the demand and the property. First day 0 demand. Second day 1 demand, 2 day, 3, 4. Depends upon the case. Demand probability also getting to vary. So 0.10, 0.25, 0.35, 0.2, 0.21 and 0.09. After that, you do for the cumulative probability of what you are going to measure for the your event. Then you make to do for the cumulative probability 0.1, 0.35, 0.7, 0.91, 1. Then at the same time, we go for the lead time also. We do for the simulation inventory policy. So the time is going to exceed more than what you are going to fix, what will be happen. Then the cost also increasing. That cost who is going to back, whether the company or whether the subscriber. That we need to measure. Here I take for the distribution of lead time. Okay, that will be lead time for the day as well as the probability. If one lead time it's represented as 0.0 0.60. That cumulative probability is represented 0.600. Then next day, we go for the 30. Okay, we go for the 30 cases. So in this 30 case, the cumulative probability is represented as you must add for the 0.63 plus 0.3. Then we got the 0.9. Next case, the inventory, the probability is represented as a 1. The probability of cumulative distribution also 0.3 plus 0.1 is represented as a 1. Now it will be going to consider, or it is going to show that the probability always 1 only. So next case, here I take for the same, for the daily newspaper condition, or we should take for the any other condition. I take for the up to 25 days what the process is going to happen. We make to measure for the cycle. Okay, how many frequency they're using. First is 0, second one is 1, third one is 2, and fourth one is 36 to 34 to 38, and fifth one is represented as 5. Okay, so then we may do for the cycle based on the events action. Then day wise cycle we need to measure. So if it's 0 in the sense 5 automatically, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here maintaining for the daily wise, daily with the cycle. Then after being in inventory, first day there is no inventory set. Okay, there is no set. So after that it will be have for the 3, 1, 8. So many being the inventory cases. In this case, we need to measure for the demand. Demand depends upon the request. Okay, 2, 2, 2, 1, 2, 1, 2, 3, 2, 3, like that one we may put for the demand. Then demand you may calculate for the how much demand is going to happen. Then after ending the inventory, what the inventory is going to complete it, after complete how much cost is there. That also we make to measure that. Based on the measurement we do for the level performance. Finally, you go for short quantity or shortage of quantity. So some of the day it will be have the shortage. Remaining day it will be not possible to shortage. That shortage I represent 14. That 14 I give for a probability of 2 by 14. Then after that, pending of others, lead time, day wise order arrival. This also we need to measure. This will be not going to have the concept. It will be going to vary together. Finally, we make to conclude that demand is 2.04 and even inventory is 69. Next case, how the inventory is going to have for the histogram values. See here what will be going to happen. We use for the 25 inventories. This 25 inventory, it will be going to have the histogram value of 0 to 1. There is no occurrence. After 1 to 5, it will be going to have so many occurrence. If, for example, we have so many occurrence, those occurrence will be values equal to 4, 42, 9, and 8. See here, what the time cycle we taken? 0 to 5 we taken for the cycle. Based on the time cycle, we may measure. Maximum is 5 and it started for the 0. 0 is represented as 0. There is no action. After one, it's going to have the 9. Then it will be have the 41, 42. And next one is a 28. This is a way we can draw for the histogram value to identify for the order. Now we can say where the maximum order is happen in between the 2 to 3 and 3 to 4. This duration only is going to happen for the maximum inventory cases of delivery. For next case, if you need to find for the order of probability, we go for the order of up to level, order up to level, then ending of inventory, then minus of own inventory, then plus of startage of inventory. These are the inventories very very essential while we do for the process. One is order quality is equal to order up to level minus of ending the inventory minus on order plus shortage of quality. Next, we go for the hitting target. Okay, up to two we studied for the what the inventory is there. Now we go for the hitting target. That third case. In this hitting target, we should follow for the few steps. One is project motion, target dynamic, physical modeling, and error factor and collision detection. First, we go for the project motion. We measure for the initially speed and angle. This is the velocity at which the project is launched and the angle at which it is find the critical. So this is called for the initial speed and angle. When we start for the initial speed, we should start for the slope. Then after it's a lunge and angle which is a field or critical. Next we must to measure for the cavity or gravity. The force of gravity will be case the project to follow a curved path and raise resistance in the air. Drug or air resist can be slow down project. It's affecting the range and accuracy than wind. Wind can also be a vector that change the project path and it move through its air. Next, dynamic cases, target cases. We have the three cases: position, size, and reaction. Based on the position, size, and reaction, the cost is increasing. The target may be stationary or move. The target size is going to have further influence how difficult it is to hit. Reaction if the target is interactive. Next, we go for the physical model. Basic simulation refer to the Newton physics. If more complex mode can incorporate realistic force like wind resistance, drag, and gravity, the arrangement of least and until the vector can be calculated using the kinetic equation. Next, error factor. Accuracy. The error factor is going to make to measure for the accuracy. That accuracy and precision. Real life scenario. Shorter really hit the exact carrier of target. The simulation condition. The factor of inventory adding some randomness or probability of distribution. Next is collision detection. Digital simulation, especially the video game or visual reality system, collision is detected. What we going to do? If we are going to using for the two or three people to play for the cricket, the collision is going to happen. Okay. For here, digital simulation, especially video game or visual reality system, collision determined along algorithm determined when the projective interactive with the target. Once a collision is detected, the simulation might register a hit and trigger some event. Okay, this 5 point is necessary when you are doing for the hitting target. We take for some example. Okay, consider the bomb attacking part. This is the ammunition parts as shown in figure. This bomb has covered range than lesser guide weapon. If bomb fall anywhere inside the target, the hit is scored. Otherwise, the bomb is missing. No, here I take for the minus 400. This is given minus 400 to 300. Okay. This here, this boundary, the targets are there. If we make to find exact position, the targets are hitting. Otherwise, what will be happen? There will be move for the some kind of cases. So while we develop for this one, we must follow for the some step. The model determine that mathematically heat has occurred using the xy coordinate. Piecewise line boundary of the part. The bomber files in the horizontal direction and carrying the 10 bombs. The, the aiming point always we focus for the 0 and the 0 only. The normally distribution around the aiming point with standard deviation up to 400 meter in the direction of flighting the 200 meter in the perpendicular direction. Standard normalization that's having mean 0 and the standard deviation is distributed. The distribution I represent is that equal to x minus or mu by sigma. X is a random variable, mu is mean, standard deviation per sigma depends upon the target. X is normal random variable, mu is mean of distribution of x, sigma is standard deviation of x. The mean is 0 and the standard deviation is 0. Then del of x equal to 400 and del of y equal to 1. That is mean is 0, standard deviation also we consider 0. As per the standard deviation, we receive for the del of 400, del of 200. So now I represent for the probability density function x equal to 400 zi, y equal to 200 zi, where x and y are simulated coordinate when the bomb is hit. For here bomb I take for the number of bomb as 1 to 10 bombs are there. In the x direction there is no problem. But in the y direction, what will be happen? It's not for the minus value. You need to rectify for the minus value. Okay. If the minus value is going to happen, the target is going to hit in the range. But so in the figure, point of impact of earth bomb. So the x is 89.1, then second hit is going to have the minus 125, 7.3. Like that, we are going to have the how many numbers are there. You may increase for the some numbers. Then after that, you measure for the what the probability in the y direction. Then based on this one, we set for the some level, that is 22 level. Based on this list level, we won't take money from the customer. Okay. So this is the way we are going to explaining for the moving target. This is a frequency response analysis of moving target in the bomb. Yeah. Up to this much, I'm going to stop in the session. Remaining thing we will see for the next.
Like, share and subscribe. Hit the bell icon for more updates.